Good afternoon, everyone. First of all, we would like to thank every one of you for this opportunity. We are very grateful and honored to be here. My name is Yadana Pachoratanasak.
My name is Napathanan Pawina Kyetikun.
My name is Kanyarat Apichat, and we are from Chalam Kwan Street School, Thailand.
Ladies and gentlemen, fellow contestants, panels, and guests, imagine this. Every plastic bottle you've ever used is still somewhere on Earth today. It didn't disappear, it didn't decompose. It became part of a growing problem that affects our oceans, our land, and even our health. Plastic takes hundreds of years to break down, and during that time, it harms animals, pollutes the environment, and clogs our cities. If we don't find better ways to manage plastic waste, this problem will only continue to grow. An anonymous person once said, "The greatest threat our Mother Earth is facing is the thinking of people that somebody will save it." This saying inspired us with our science project. Distinguished panels and guests, we are currently facing a global plastic pollution disaster that demands more than just incremental change. It requires a structural revolution. That's why our research titled From Waste to Pathwalks, Evaluating the Compressive Strength of Plastic-Infused Eco-Bricks in Low-Load Construction explores a sustainable alternative to traditional masonry. This study is anchored mainly in major hurdles that we are facing today, most specifically, the adverse environmental impact of plastic pollution and the often low compressive strength found in recycled alternative construction materials using plastic. However, the potential for success is significant. By modifying bricks using PET plastic, we can reduce water absorption to a mere 6.95%, which drastically extends the material's lifespan by preventing internal moisture degradation.
Beyond environmental durability, there is a compelling economic and social case. In high-need area, transitioning to PET bottle brick can result in a 54% reduction in construction costs. This click-together or manual system empower local community through sweat equity, allowing residents to transform waste into a valuable asset for long-term economic stability. In response to the challenges we've identified regarding environmental impact and structural integrity, we propose a targeted solution, EcoBrick. Our approach does not just look at recycling plastic, but at infusing it into the very fabric of the building material. We have developed a process to evaluate the performance of brick. Does not just look at recycling plastic, but at infusing it into the very fabric of the building material. We have developed a process to evaluate the performance of brick, specifically infused with plastic strip and plastic chip. This intervention is designed to transform problematic waste into a functional construction component, creating a pathway for sustainable low-load infrastructure. Our study specifically evaluated the compressive strength and the acceptability of brick infused with plastic strip versus plastic chip to find the most viable path forward.
Our methodology followed a rigorous product development design, ensuring that each brick was manufactured under controlled conditions. The process was categorized into 5 distinct stages: preparation and construction. This involves gathering raw materials and the custom fabrication of brick molders. Mixing and molding. Precise measuring and mixing were conducted before the infusion of plastic strips and chips. Curing. Bricks underwent a standardized drying and curing period to ensure material stabilization. Structural testing. We utilized the compression testing machine to provide empirical data on the load-bearing capacity of each variant. Qualitative assessment. A scorecard system was implemented to evaluate the acceptability of the product in terms of design and appropriateness. To ensure statistical integrity, we applied measures of central tendency and documented our findings through rigorous observation and recording. The results of our testing provide a clear hierarchy of performance. The eco bricks infused with plastic strips emerged as the superior variant. Structural strength. This variant achieves a compressive strength of 724 psi or 4.99 MPa. Performance boost. This represents a remarkable 72.38% increase in strength compared to our control group. Regulatory standards. Crucially, these results surpass the minimum compressive strength required for non-load-bearing masonry.
In terms of acceptability, our evaluation covering color, design, appropriateness, durability, and overall acceptability resulted in a high rating for both the plastic strips and plastic chips.
In addition, to further validate the finding, the researcher used analysis of variance or ANOVA to determine whether significant differences existed among the compressive strength resolved the control group, plastic strip infilled eco-brick, and plastic chip infilled eco-brick. This statistical test helped identify whether the observed differences were statistically significant and determine the most effective plastic infusion treatment for low-load construction application.
To conclude, while these eco-bricks are not yet suitable for heavy load-bearing structures, they represent an ideal and cost-effective material for low-load carrying masonry, such as pedestrian pathwalks. By utilizing the plastic strips, we can create a construction material that is not only structurally sound, but also a direct solution to the plastic crisis. We believe this research paves the way for a greener, more resilient community infrastructure. Now, allow us to show you our documentations into making this project. This is us cutting the plastic strips and chips.
This is us preparing and mixing our mixture.
This is a pouring of the mixture in the mortar.
This is us arranging the eco-bricks.
This is us doing the compressive strength test, and we apologize for the spelling mistake.
This slide shows acceptability survey scorecard.
And this is our computation sheets for the one-way ANOVA.
This is our computation sheets for the compressive strength test. This is an example of what we can use our eco-bricks for, which are path walks. This photo shows our bricks arranged in front of our building.
And the last one is references.
Thank you for listening.
We are now ready to answer your questions.
Thank you. It's a very wonderful presentations for today. Okay, please questions or comments for this group, please.
This is our sample product that we brought from home.
Thank you, Mr. Chairman. Thank you for your presentation. I really appreciate it. I have only one question. Please back to the last slide. One more. Yes. This is a beautiful pathway from recycled plastic brick, and I see a lot of many plastic blocks you used to what is the production capacity of of your recycle brick?
We have a limited capacity in making, but we decided to carefully make them like one by one. In one pair, we can make 3 bricks, and it took a lot of time, but we made the bricks come true.
How many days?
It took 5 days for the curing period, and we repeated the process.
Could you please explain the detail to test the compressive strength of the eco brick?
We use the compression testing machine, which is the photo over there.
When we press the machine, it will press our bricks, which will tell the number in the hydraulic press, which gets us the MPa,
which is 724 psi.
Okay, thank you.
Thank you. Okay, it's very nice. I just only last one questions for this. Actually, I think it's a very wonderful project, and I argue in your opinion, is if you want is like make the brick eco brick is stronger more than now. In your opinion, how you do?
Right now, we are actually studying into how to make it more durable, and actually we thought of adding more plastic, but it didn't work, so we increased the curing period, which even like if we have more time, the bricks will solidify more, so making it more durable.
That's okay. Thank you very much.
I love the way you create a very bright and clear and informative slide, even though some will be AI created, but it's very nice, really. Yes, one question is, not a question actually, it should be a comment, okay? When you try to mix your plastic strip or the chip into that, one of the best thing for the brick is it can overcome all the compressive force you push into it. But once you try to pull it apart, we call the tensile stress, okay? It's very weak. So be careful when you try to mix when you have to precisely calculate the ratio of the plastic you put it in. It must not be, higher than 50% or something like that. Otherwise, when you try to put it under what we call the shear stress, once you push it this way and push it that way, it will be very weak. So be careful. But anyway, you use it as, footpaths. That's quite easy to control. So if you can control a compressive, a tensile, and then the shear force, then you're going to be a very good engineer. Thank you very much.
We will put this into what we want to do next.
Okay, thank you very much. Thank you for a wonderful presentation. Yes.